Okay, so in this question, we are given a right angle triangle and the sides are given 8, 6, 10. Okay, so since these numbers are Pythagorean triples, so that means the angle right here is 90 degrees. Okay, we are looking for the area of the shaded region that is given n pi, and then what is that? Okay, so first of all, let's actually go ahead and write those numbers. Maybe that will be 10. So probably it doesn't really matter what side like that I choose for 6 and 8. So I'm gonna maybe choose this side to be 6 and this side to be 8, and this is 90 degrees. Okay, so the area of this right triangle is 8 times 6 over 2. That is already we are given, and maybe I can find the area of the same triangle maybe differently. Okay, so but whenever you are given a like circle, and if you have some tangency points or line like crossing as a tangent, then it's really important for us to connect those tangency points with this center point. So most of the case it's going to be really helpful. So if I just connect that point to each tangency point, so that should give us this picture. So when we connect these points, like center point to tangency point, the angle will be all 90 degrees. Okay, so these are 90 degrees. So what I'm going to do now, I'm going to go ahead and connect the center point to the each corner, because I'm going to find the area of the triangle in a different way. So then we will just find the area two different ways and make an equation to find the radius. Okay, so what I'm going to say, let's assume this is radius, and that will be radius, that is also radius. And if I want to maybe find the area of this triangle, okay, so that is going to be actually 6 times r divided by 2. Okay, and if I like to find this triangle, this is r times 10 over 2, so that should be 10 times r over 2, and plus the area of this triangle will be 8 times r over 2, so that should be 8r over 2, and this is also equal to area of this right angle triangle, which is 8 times 6 over 2, so that will be 6, 16, 20, 24, take the half, so that should be 12r, which is equal to 24. Okay, so then r will be just, which is good. Okay, so we have the radius of this small circle as 2, and the question is, how do you find the area of the larger circle? So in order to find the area of the larger circle, we should know about the radius of the larger circle. But at the same time, we are given a right angle right there, and whenever you are given a right triangle and facing the a side in the circle, that side actually is going to be our diameter. So this hypotenuse is going to be the the diameter of this larger circle. So if you don't know about this feature, you can actually take a look at some angles, and there are some like angle like chasing. So we can see that whenever we are given a right angle triangle in a triangle, like in a circle actually, the hypotenuse will be diameter. Okay, so let me actually go ahead and talk about this a little bit as well, just to make sure. So let's assume this is a, okay, let me actually try drawing a circle first. Okay, so I'm gonna have this circle, and what I'm gonna do, I'm gonna actually have a diameter, and this is our diameter. Okay, and I'm gonna have a triangle, and one of the sides of that triangle will be diameter of the triangle, the circle. Okay, but for now, I don't know about this angle yet, but based on what I said, this angle needs to be 90 degrees. Okay, but in order to prove that, this is just one way to look at it, so it's not really the only way. So, but that's gonna be probably the easiest one. So if I connect this center point to that corner, I do know, I do have, this is radius, this is radius, and this is radius. Okay, so if I call this angle as alpha, and this angle is gonna be alpha as well, because isosceles triangle, and this angle right here, so alpha plus alpha will be 2 alpha, that's the exterior angle rule, or you can just find this part as 1a minus 2 alpha, so that should be 2 alpha anyway. And now I like to get this angle and this angle. So I'm going to call this angle as beta, and let's call this is beta. So in this triangle, and this is our center point, and 2 beta plus 2 alpha is equal to 180. So alpha plus beta is going to be just 90 degrees. Okay, so that tells us this angle right here is going to be 90 degrees. So again, we did not choose any specific value for those angles. We just make it in general. So whenever you are given a triangle, okay, one side of the triangle, if that is like a diameter, that means the angle opposite that diameter is going to be 90 degrees. Okay, so that's why this is going to be our diameter. So this side is 10, so that means radius of the larger circle is 5. So I'm going to call that radius as 5. So the area of the larger circle is pi 5 squared, and the area of the smaller circle is pi r squared. R was 2, so that should be 2 squared. 25 minus 4 will be 21 pi. And the question was asking the number right here, so that should be just 21, okay? So that's the answer for problem 19.